This is an introduction to absolute value equations. Absolute value equations are equations in which there's an absolute value, and within the absolute value there is a variable. That's where the variable is located. Before we get started talking about the equations themselves, let's just remind ourselves what is the absolute value of a number. The absolute value of a number is its distance from 0. We might also think of it as the magnitude of that number. When we think about distance, distance is a non-negative value. So if I take 3 steps this way, I've gone a distance of 3 steps. If I take 3 steps backwards, I still went a distance of 3 steps. Even though I went backwards and I went back the way I came, that doesn't make it -3. Absolute value is a distance, and a distance is always a non-negative value. The notation for absolute value would look something like this. So we see the term or the expression within the absolute value. These things are called the absolute value bars. And the way that we read this is read the absolute value of x. Absolute value is a special type of grouping symbol that we'll talk more about in just a minute. And we're just going to look at some examples here. So we're going to be talking about absolute value equations, such as this. So we have a variable inside the absolute value equals something else. There are 3 things that we want to consider with these absolute value equations, and that's what is A? What if A is positive? So we're going to assume here, and A is bigger than 0. So A is positive here. So if we're going to solve this equation, then inside the absolute value bars, either x could equal A, or, because the absolute value of A is A, or x could equal -A. Because if we plug in -A here, the absolute value of -A would also be A. So if we have an absolute value equation where the absolute value is equal to something positive, we have 2 cases to consider. If we have an absolute value equation and the absolute value is equal to 0, well, there's only one way for that to happen. The only way that the absolute value of something is 0 is when what's inside is 0 itself. Because remember, 0 does not have a sign. It's neither positive nor negative, and it's 0 units away from itself. So in this case, we would say x is equal to 0. One case when x is, the absolute value is equal to 0. And the third thing to consider, what happens if we have the absolute value of x is equal to A, and A is negative, A is smaller than 0. What we're being asked here is to find a magnitude, a distance from 0 that is equal to something negative. That's not possible. So if we come across something like this, the absolute value of x is equal to -4, the absolute value of x is equal to -10, it's impossible. We say there is no solution. So we would represent this no solution. There are a few other ways that we can represent no solution. If we're using interval notation, what we do is we open up a set of braces. So braces are the really fancy grouping symbols. If you're not very good at braces, because they do require a special skill, if you just do squiggles, it looks just like braces. So if you just go like this, kind of looks like the same thing, and your professor totally understands, and that's cool too. But what we would do is we would have a set of braces with nothing inside, representing the fact that there was nothing that was a solution. The third thing you can do in set theory notation is you can say it's the empty set, which we represent. It's kind of like a 0 with a negation through it. That represents the empty set. That means that there was no solution to that particular equation. So this is what we're talking about with absolute value equations. Now I do want to talk about the suggested steps for solving an equation that contains an absolute value. Step 1 is you want to isolate the absolute value, the expression within the absolute value. We want to isolate the absolute value term. So first, isolate the absolute value term. Isolate the term containing the absolute value. Switch over here, the absolute value. So if there's something being added or subtracted to it, move it to the other side. Treat the absolute value bars like a variable itself and move everything away from it. Second, if it has a coefficient, we want to divide both sides by the coefficient. If the coefficient doesn't equal 1, divide both sides by the coefficient. And And I'm going to be lazy here. I'm just going to say by it instead of by the coefficient because that is fewer words. I want to talk about this. This is really important because I mentioned before that absolute value is a special type of grouping symbol. So if, for example, we have -3 times the absolute value of x plus 2 equals -6, we do not distribute within an absolute value. It is incorrect mathematically to do that. Do not do that. It is mathematically wrong. What we really want to do is we want to divide both sides by -3. That's going to isolate the absolute value. Yes, it is a grouping symbol, but no, it does not have that rule. It's not the same as parentheses or braces or brackets where we would be able to distribute. We cannot distribute within an absolute value bar. Nothing can get inside the absolute value bar. So we divide both sides by the coefficient. Once we have that, so if we look at what we're left with, we have the absolute value of x plus 2 is equal to 2. Once we have this, the absolute value is by itself, the coefficient's 1. Now we want to determine, okay, how many solutions are there? We determine the number of solutions going back here, whether the right-hand side, the other side is positive, 0, or negative. So here it's a positive, which means we're going to have 2 cases to consider. If it was 0, we would have 1 case to consider. If it was negative right here, we have an absolute value equals something negative, we would say there is no solution. So step 3, determine the number of cases, determine the number of solutions. The number of solutions. And set up the cases. When we set up the cases, what we're looking at is we're looking at the value inside the absolute value bars. So when we're looking at the 2 cases, well, in this case there would be 2 cases, when we look at those, we do not include the absolute value bars themselves, because what we're saying is we're saying that this thing inside can either equal +2 or -2. And so once we're considering the cases, we do not include the absolute value bars. We just figure out what the 2 values are for x.